Okay, good morning class. You're all to Mami with Jarvis, and today we'll be looking at geometry, taking into consideration our grade 8 experience. We'll continue with the series that talks about quadrilaterals, and we'll be concluding that today. We are left with one major type of quadrilateral, which is actually called a trapezium. And what's a trapezium? Essentially, a trapezium is a quadrilateral that has one pair of opposite side. That has what? One pair of what? Opposite side. So by way of diagram, we can draw a trapezium to look more like this. There are different versions to what a trapezium can be. Now this is one type. That's one type. And there's yet another type. The one on top is what we call the Isosceles Trapezium. It's a unique type of trapezium, while the one beneath that, this one, is just called a trapezium. Generally, when we're talking about trapezium, this is what we're talking about. There are different versions to that, but we have a special type, and it's important we understand this type of trapezium. So I'll start by talking about what we call the Isosceles Trapezium. So what's an Isosceles Trapezium? The word isosceles will suggest from our early knowledge of triangles that the base angles are equal. So for the Isosceles Trapezium, we would expect that this angle will be equal to this angle. This angle will be equal to this angle. And by way of diagram too, we expect that this angle too will be equal to this angle. So there are some interesting properties we can see by reason of its spatial appearance. For one, we can have one line of symmetry. The line of symmetry can cut this such that we have what we have here being exactly equal to what we have on our left-hand side being equal to our right-hand side. So, but generally, this is just a special type of trapezium we need to take note of. Because sometimes in the exam, we see examiners try to match properties of shapes to come up with a very unique shape. So, keep in mind that there's something called an isosceles trapezium, and this is what it looks like. Having said that, let's look at what we may call the general properties of the trapezium. So, properties of trapezium. As is said by the definition, number one, we expect it to have one pair of opposite sides parallel. Notice I said parallel, not equal. One pair of opposite sides what? Parallel. So we expect that one pair of the opposite sides will be what? Parallel. That appears to be the most unique property in the trapezium, because aside that, every other thing, for instance, the diagonals do not bisect. Diagonals do not bisect. Even when we talk about diagonals intersecting, we don't expect anything too special when we talk about the trapezium. So by way of extending my narrative, if I cut like this is one diagonal, I cut like this. These diagonals don't bisect. Although they intersect, they do not what? Bisect. So diagonals do not bisect, but they what? Intersect. So that's about what we may talk about when we mention the trapezium. There's nothing so special aside these properties. My narrative, or my best approach when I look at shapes, I try to talk more about them when we bring them into comparison with other shapes, or when we attempt to answer questions, because sometimes It's not enough to just be able to list them. It's more important for you to be able to remember them. And sometimes remembering them will require that you use the properties from time to time. So having talked about our trapezium, the next thing we're going to try to do is to do some kind of classification. Okay, what we have on the board is a summary of the topic quadrilaterals. Quadrilaterals is such an important topic that some of the conclusions you're going to be hearing today will really stun you. We have what is called the relationship tree. I chose to call it that, the relationship tree of quadrilaterals. And I have what I have here, a summary of quadrilaterals. Now, quadrilaterals generally are broken down into two types. We have the parallelograms, and let's make that plural. And we have what is called the non-parallelograms. Now, under parallelograms, we have parallelograms as a special type, that is, parallelograms that are neither rhombuses, rectangles, or squares. So, parallelogram is the family name. Just like sometimes my father is called Jarvis, and I'm called Jarvis too. You get it? So, as a son, I'm Jarvis, but under the broad name Jarvis. So, that's how it is. So, this is parallelogram. We have squares, we have rectangles, we have rhombuses, and we have parallelogram. All coming under the family called what? Parallelogram. We have what is called non-parallelograms. Other non-parallelograms, we have things like kites, we have trapezium, and any other quadrilateral, irregular quadrilateral that is not a parallelogram. Now that takes care of a summary of our parallelogram. Now we come to our parallelogram tree, and this is where I really need you to pay very, very close attention. I'll start by identifying all the diagrams I have on the board. I try to draw them showing their unique properties. This is the quadrilateral where I'm coming to. You notice that there are arrows pointing up. I'll come to explain that much later. This is trapezium, this is your kite, this is your parallelogram, this is your rhombus, this is your rectangle, this is your square, and that takes care of everything here. Now the arrow direction tells you where particular shapes can be under. If you look at the last part, we have what is called a square. I seen it. This is square. A square, know that all the sides are equal, all the angles are equal to 90 degrees. A square is a rectangle, and a square also is a rhombus. A square is a rectangle, and a square is also a rhombus. Now, we move up the tree. A rectangle is a parallelogram. So anytime you hear a rectangle, know that that rectangle is a special type of what? Parallelogram. And also, a rhombus is also a parallelogram. Watch the arrow. The arrow is what you should be looking at. The arrow means that I am going back to my master. I belong somewhere. The rectangle and the rhombus all belong to your parallelogram. Now, something that will rather stun you here is this. A rhombus also is a kite. A rhombus is also a kite. Are you surprised about that? So what it means is that a rhombus is a special type of kite. You need to pay attention to it because in your NECO Junior WAEC, or what we call the BEC, there are questions like this that come. So you need to mark this diagram and take this video very seriously. I would advise you to watch this video up to 15 times because it has to stick into your head. Now, let's watch this. A trapezium, please watch this. A parallelogram is a trapezium, which means that a parallelogram is a special type of trapezium. This is the tree. So, if by way of understanding, we have two major types of quadrilaterals by looking at the relationship tree of quadrilaterals, it means we have a trapezium and a kite. Every other quadrilateral type you have come from these broad groups. Either they are trapezium or they are what? The kites. I hope you have enjoyed it too. So this is what it is. And I want you to go back and really study this. So I could ask you, in a true or false question, is a kite, or let's say, is a rhombus a kite? Yes. Is a rhombus a parallelogram? Yes. Is a parallelogram a trapezium? Oh yes. So your answer is born out of looking at the direction of the arrows. Is a square a rectangle? Oh yes. Is a square a rhombus? Oh yes, because the direction of the arrows are going in this way. So it's important you go back and study this. I'm really thrilled by the information I'm passing across to you today, and I'm trusting that in concluding this topic today, you would have gained something very important and what? Symbolic. We're going to continue shortly by looking at what we may call angles in a polygon. Mama will return. Don't go away.